Hello everybody, I hope you did well in your quiz. I am here to teach you about U substitution, so even though I'm absent, you still get to hear my beautiful voice. So here we go.
I see you arriving in class during calculus, and you got f of u, which you want to find the derivative of. It's just f prime u and a du2.
Alright, that's enough of that. I thought you'd enjoy hearing it just a little bit. So if you remember on Tuesday, we talked about the chain rule, okay, which is finding the derivative of a composition of functions. So it's the derivative of the outer. Oops, I didn't mean to move that around. All right, so derivative of the outer times the derivative of the inner function. So our goal is to go backwards today and be able to integrate a composition of functions and get it back to its original state. So these were the problems that we did with the chain rule. In case you didn't get to check your work, here are your answers. Okay? And now, okay, we're going to talk about when we do the integral of these types of functions, what's important is that we need to be able to look at the function that's being integrated right here and say, what's my inside function and what's my outside function? So the inside function for us is almost always going to be the part that's raised to a power. So for here, the g of x, that's your inside function, is x squared plus 1. And then we're going to be taking that and putting it inside x to the fourth. So that's your, I didn't write that well, that's your outer function here, okay? And this is your inside function, okay? So the composition would be x squared plus 1 to the fourth, okay? And then the other thing that you're going to have to identify when you look at this is what is the derivative of the inner function. So the derivative of the inner function of x squared we know is going to be 2x. And that, we hope, also appears in here. And for us, it doesn't necessarily look like it does, okay? So we want to be able to find it. In 10x, I can find a 2x. It's 5 times 2x. And we'll talk about what that extra 5 is later, but for now you don't have to worry about it. So let's look at our next one. So the next side, it's easy to tell that the inside function is going to be x cubed plus 1, which means our outside function is that square root. So it's x to the 1/2. So the composition becomes x cubed plus 1 to the 1/2. And now you can also take a look and say, well, what's the derivative of my inside function? The derivative of x cubed is 3x squared, okay? And you can also add on your dx, which I forgot to do up here, okay? And I can look in here and say, oh, it doesn't look like 3x squared is there, but it actually is. 9/2 can be broken down to 3 over 2 times 3. So you're going to be looking for all of these different parts when you take the integral. So I want you to pause this video for a minute and see if you can identify the inner and the outer functions of the next two. All right, so let's see if you got your answer right. So for our next one, for g of x, our inner function is x to the fourth plus 1, and my outer function is x to the third. And eventually we're going to call that u, okay? And our composition of functions is x to the fourth plus 1 to the third. And the derivative of g of x is going to be 4x to the third. And looky here, I've got it, okay, which is very exciting news. Okay, and then for our last one, let me move this up a little so you can see it, okay? The inner function, this one might be a little bit trickier for you to see, okay, because it's on the bottom, but the inner function is still what's being raised inside to the power. So it's going to be our 2x plus 5, okay? And our f of x will be x to the 1/2. So when you have the composition, sorry, that should be a negative 1/2, it'll be 2x plus 5 to the negative 1/2. And then finally, when I look for my derivative of my g prime of x, that would be 2x dx. Just kidding, I hope you caught my mistake. Okay, so it would actually just get rid of that x there. It would be 2 dx. All right, so now that you can kind of look at this and identify parts, we're going to move forward so that we can do this u substitution. So we're actually, for now, we are going to skip this page. If I were here with you, I would be doing this with you, but that's okay. We're going to skip today. And along with this one, we're going to come back to this concept after. Okay, this was more of a discovery activity. So we are going to skip this. Okay, so the method that we use to take these integrals is called u substitution. So let me tell you about it. I know that you're going to be super excited to learn all about this u substitution right here. So the first thing that you've kind of already done a little bit is being able to look at a function right here and tell what is the inner function, what's the outer function, and then we're also going to have to look for the derivative in the function. So u becomes like our g of x. It becomes our inner function, and what we call du is the derivative of the inner function. So that's really your first task, is say, what is the inner function and what's its derivative? And then we're going to integrate from there. So if you begin these examples, so if you notice we've been following the same examples all the way through, our inner function here, our u, is going to be x squared plus 1, and our du is going to be 2x dx. And don't forget that dx. Okay, so here our inner function will be x cubed plus 1, and our du will be 3x squared dx. And this will be the first part of the assignment that you do tomorrow, is just being able to identify that inner and outer function, okay, and their derivatives. So again here, our u is going to be x to the 4th plus 1. It's that function on the inside that's being raised to the power. You're going to learn that everything outside of what's being raised to the power is going to be something to do with your derivative, likely. Okay, so our derivative of here is 4x to the 3rd dx. Okay, and our last part here, our inner function would be the, I might have paused it there for a second. It'll be the 2x plus 5, and your derivative will be 2 dx. So now we need to move on to be able to talk about what are the actual rules for doing the u substitution method. Okay, so now we're going to talk about our steps for u substitution before we put them into action, or as it says up here, u substitution. A little typo up there. So your first step is, just understanding the idea that we are integrating, okay, a composition of functions. So you're going to be looking at this format, f of g of x. You're integrating a composition of functions, and then you'll see g prime of x dx. And obviously we're trying to get to the bigger function, the big F. Okay, so your very first step when you're looking at this is that you need to identify the u and the du. So, we talked doing the chain rule about using the u method, and in this case we are going to have to use it all the time. So your first step is to ID the u and the du in the integrand. Okay, the integrand, that's what's underneath or in the integral. Okay, so you just want to remember that u is equal to g of x, and du is equal to g prime of x. Okay, our next step, which we're going to come back to, sorry, I paused it again. I keep on hitting it with my hand, and I'm not going to start over, is to determine if you're missing something. So determine if you're missing something from the g prime of x. Okay, so that's going to be a standard rule. Are we missing something from the g prime of x? Because you might be missing a 5 or a 3 based on what the integral should, or the derivative should be. And we're going to then do, after we determine if something is missing, we're going to do a rewrite of the integral, okay, by multiplying and dividing by a constant. Okay, and then the next step after we do that, and like I said, we'll that's going to come along and you'll understand what I mean later, is we are going to rewrite the integral in terms of u. Okay, so that's going to be our u substitution. And then the next part that we'll do is once we've rewritten it in terms of u, is we will integrate, okay, and then we'll rewrite our x's, okay. We'll rewrite in terms of x, okay. And don't forget, when we're taking the integral, we want to remember our plus c, okay, because we're going to have to be adding that on. So here we go. All right, I'm just making sure you're on the train with me. Told you I tried to keep this one entertaining. So let's begin. So in this one, and we're continuing with our same examples, and then we'll mix in new ones. So we've already talked about this one, that we know our u is x squared plus 1, and our du is 2x dx. So I've got that piece of information. So when I look at it, my integral, I say, do I have my u in there? Yes. Do I have my du in there? And I do. I can't see it as plain as day, but I'm going to rewrite this to 5 times 2x. So I can rewrite this as 5 times 2x times the integral of x squared plus 1 to the 4th dx. So that's my first step in the process. I identified my u and my du. Okay, and now I'm just going to make sure I can see that they're in the integrand. Okay, so what I'm then going to do is I'm going to do a rewrite. Okay, so I am going to change this to, instead of x squared plus 4, right here, I'm going to replace that with u. So it's going to become the integral, okay, and we're going to come back to the other part, so of u, okay, and that's, okay, the same thing under there, the x squared plus 1, we'll say u to the 4th. That's a 4 there. Right? And then instead of having the 2x dx, this part, we're going to replace it with du. So now I've got u du right here. And then the 5 is the only thing here that I can't replace anything, so I'm going to bring it along for the ride. So now I can actually do integrating, and you guys are pros at this now. So I integrate u to the 4th with respect to u, so that means I have to go up to the 5th power, and I would divide by the 5th power too, and knowing I'm not always going to write that, okay, and then that would be plus c, or in other words, u to the 5th plus c. So there's my step where I integrated, and my very last step is I need to rewrite this answer in terms of x. I need to get it back up to using x squared plus 1. So it will become x squared plus 1, I go back to what u is, to the 5th plus c. Okay, and the great thing about these, just like when we learned integrals before, is I can take my derivative and see if I end up back at my original function that's in the integrand. So if I wanted to say, okay, take the derivative of this, the 5 would go in front using the chain rule. I promise I won't sing the song again. Maybe. X squared plus 1, we bring it down to the 4th power, times the derivative of the inside, which is 2x. Derivative of c we know is 0. So that would come out to 10 times 10x times x squared plus 1 to the fourth, which is exactly what we started with. Okay, so that's the beauty of these problems, again, that you can figure out what your answer should be because you can check it in the end. So let's take our next one. Again, we already identified u as x to the third plus 1, and our du should be 3x squared. And again, now our job is to identify within the integral here. Okay, so if I want to take a peek here at my integral and see if it has all of these parts. Does it have the u? Well, we figured it out from there. And is the du in there? Okay, so I need to be able to take that and break it apart. So for me, I'm going to say 3x squared is in here, okay, because I can take 9 halves and change it to 3 halves times 3x squared times x to the third plus 1 dx. Okay, let me move this up a little so we got some room. And again, right, now I'm going to do my rewrite. So I know that u is x cubed plus 1. So I'm going to take this integral, and I'm going to say now this is equal to u to the 1/2. Okay, so I'm taking my x cubed plus 1, and I'm just raising it to the 1/2, which is my square root. And then my du I've got in there, so du here, 3x squared, that's my 3x squared dx, right? So I can now write du here, and again, I've got something I didn't do anything with, so that 3 halves is going to come with us, right? And we're just going to keep it in there because I didn't replace it with any of the u's. So now my job is to integrate. So I go up to a power, so up a power of 1 from 1/2 is u to the 3 halves. And I know I'd have to divide it by 3 halves, so I'll just have a 1 in front of there, and then plus c, right? And then from there, I do my final rewrite. I put it back in terms of x. So I take this u right here, and I replace it with x to the third plus 1. So now it becomes x to the third plus 1 to the 3 halves plus c. So that's your final answer here. That's the answer to that integral. And again, I can check my work by taking the derivative. So I could say, okay, if I want to take the derivative of this, bring my 3 halves down in front, reduce it by a power, so it would go to 1/2, times the derivative of the inside, which would be 3x squared. Right? And if I combine the 3 halves and the 3x squared, that would give me 9 halves x squared times x to the third plus 1 to the 1/2. And that is exactly where we started. Okay, so hopefully you're starting to catch on to this. So let's do one more example. Okay, so if I look at this one, I'm going to identify my u and my du. So I'm going to start out by saying my u is what's being raised to the power here. It's usually the function inside of another one. So my u is going to be equal to 3x to the fourth plus 2. Okay, then I say what's the derivative of that? So du is equal to 12x to the third, derivative of 2 is 0, dx. So now my job is to go back and say, do I have my derivative in there? And I can see plainly right here, these two are exactly the same. So that I can then rewrite my integral in terms of u. So I'm now going to say the integral of u to the third. So I replaced the 3x to the fourth plus 2 with u, and I still raise it to this third power. I've got my full derivative, so I can just then write du. Okay, so because that's there. So I'm replacing this 12x to the third dx with du. So it's substitution there. So now I just integrate this. And this would be 1/4 u to the fourth, bring it up a power, plus c And now I take, okay, and I figure out with replacement that it's 1/4 3x to the 4th plus 2 to the 4th plus c. And again, I could take my derivative and make sure I end up exactly with what I started with. And I do. Okay, so hopefully you're starting to see a pattern. And of course, you know me, I'm going to take it up one little notch more to see what happens if the du is not exactly there, because we saw that was the case in some of our examples as well. Of course, the bell had to ring while I was talking. I'm recording this during the lunch period, so the bell may go off a couple more times, who knows. Hopefully they're having a good lunch today. Not sure what the soup of the day is. So anyhow, okay, where was I? So we're going to begin by looking at this problem, and again, still figuring out what's our u and what's our du. So in this case, we already identified this. The u was x to the 4th plus 1, and our du should be, whoops, sorry there, should be 4x to the 3rd dx. So I begin to look over here and I say, okay, I've got my u raised to the 3rd power, but oh no! Okay, I don't have the exact du there. I've got x to the 3rd, but I don't have 4x to the 3rd. So I'm missing this 4. It doesn't appear to be right here. But by magical powers that I know that you have, we can actually add that 4 in. So what we're going to do is say, I want it to have 4x to the 3rd times x to the 4th plus 1 to the 3rd power dx. But how can I magically add that 4 in? I know you all think I have superpowers, but we have to use math to add it in. So what you have to do is multiply by 1/4 on the outside. Why, you ask? Because when I multiply by 1/4 by 4, that's like multiplying by 1. So I haven't changed my problem at all, but I've gotten everything in there that I want in there. What you have to be careful is that you don't lose this 1/4 along the way. So if we go back to our steps, there was that step that said determine if there was something missing from your du. And in this case, we were missing the 4, so we want to add it in. And in the directions, we wrote add it in by multiplying and dividing by the same number, because really that means you're just dividing by 1. So now I can do my rewrite. And when I do my rewrite, I'm going to keep that 1/4 times the integral. So now this is our u, so it'll become u to the 3rd. And then 4x to the 3rd dx is our du. So now when I integrate, okay, u to the 3rd will go up to u to the 4th. I'd have to add a 1/4 here. I also have this 1/4, so now I've got 2 plus c. So that's really equal to 1/16 u to the 4th plus c. Okay? Because when I have a number out front, I've got to remember to multiply it at the end. So the 1/4 u to the u to the 4th, that's our integrating of u to the 3rd, and then I multiply those together and I get 1/16. And then our final answer goes to 1/16 times x to the 4th plus 1 to the 4th plus c. Okay? And again, I can check my work by taking the derivative of this, and you'll find that you'll end up exactly back, okay, where you started. So let's look at this last one here. Okay, so our last one, the u is 2x plus 5, and our du is 2 dx. Sorry, I'll draw a little line there so we don't confuse that. So I look over here and I say, well, I know I've got my u, okay, under the square root, but I don't have my 2 over here. Where did it go? So I want to add that 2 in. So I would add it in there. It doesn't say 12 anymore. And I would also multiply by 1/2. So it would look like 1/2 the integral of 2. I'm going to make this 2 to the x plus 5 to the negative 1/2 dx. Okay, so I added in that 2 here, but I also multiplied by 1/2. So it allowed me to have my du without actually changing the problem. So now I'm going to do my rewrite. I'm going to bring that 1/2 with me, and I'm going to integrate. Now this is our u, so u to the negative 1/2, and then the 2x right here, the 2 dx, okay, is our du. Right, so now from there I can integrate this. So if I integrate it, it goes 1/2, right? That's my 1/2 right here, times integrating the u to the negative 1/2, which would be 2u to the 1/2. And now I add plus c. All right, so that, and gives us some more room, would then be equal to, these 2's would cancel, so u to the 1/2 plus c, which would then be 2x plus 5 to the 1/2 plus c would be your final answer. And again, I'll say it a million times over, you can take that derivative, okay, and find or see if your solution is correct. Okay, so because I love you, I've got one more for you. Okay, so let's look at this one. So it's not one that we've seen before. So I take my first step and I say, what's my u? My u is x to the 5th minus 2. What's my du? It should be 5x to the 4th dx. So I travel back over here and I say, with my handy dandy lightsaber, oh, I got a blue one this time. Do I have my u? Yep, because I picked that out. Do I have my full du? No, because all I have right here is x to the 4th. Okay, so if I only have x to the 4th, what do I need to add in? Did you say 5? That's correct. I need a 5 there. So I'm going to do a rewrite. So I would rewrite this as 1, well, it's not writing there. There we go. I'd want my 5x to the 4th times x to the 5th minus 2 to the 3rd dx, and then I'd have to add that 1/5, so it means I didn't change anything. So now I do my u rewrite. So it would be 1/5. Okay, now I've got my full du here. Okay, and I've got my u right here. So it becomes 1/5 the integral of u to the 3rd. Okay, so our u, and then our du, which is the 5x to the 4th and the dx, so du. So now I integrate that, 1/5, integrating u to the 3rd, so that goes u to the 4th, times 1/4, okay, plus c. All right, from there, that's 1/20th u to the 4th plus c. And then from there, we do our substitution, so it becomes 1/20th times x to the 5th minus 2 to the 4th plus c. So I'm hoping at this point you've caught on, okay? So I want you to take a second and pause this video and see if you can do the next 2 examples. Just take a minute, and that way you can verify that you really have a decent understanding. And because I love you again, I want you to try these. So take a minute and do these. Okay, hopefully you did take the minute and try them, and now you are, okay, just going to check your work with me. So I'm going to run through these pretty quickly. So here my u is x squared plus 1, and my du should be 2x dx. And again, I'm missing the 2. So I'm going to add that in, and sometimes I don't do a whole rewrite, I just add it in. Whoops. Okay. I just add it in here like that. Okay, so I've got my 2 there now. So now I can integrate. So I've got 1/2 the integral of, now I've got just u to the 4th du. So if I integrate that, it's 1/2 times 1/5 u to the 5th plus c. We know that 1/2 is going to be 1/10, so now it becomes 1/10. I do my replacement, so x squared plus 1 to the 5th plus c. All right, so hopefully you got that one right. And now our next one, let's come over this way. Okay, so our next one here, my u is equal to x cubed plus 1, and my du should be 3x squared. So again, I'm missing that 3. So I'm going to add that 3 in here because I want it to be there, and I'm going to multiply by 1/3 here. So now I take and I say, I'm going to rewrite it with my u's. So I'm going to go, I can't get rid of that. So I'm going to say that is 1/3 integral of u to the 1/2 du. So integrate that, it becomes 1/3 times, and now we're going up to the 3/2, so x to the 3/2, which means I need to multiply by 2/3. Did I write an x? That should be a u. Okay, plus c. So now when I multiply together, that should give me a 2/9. I'm going to do my replacement here. So my replacement becomes x to the 3rd plus 1 to the 3/2 plus c. Okay, so hopefully you successfully made it through those two problems and you're getting a good understanding of what's going on. So finally, your last pause should be to try these 4 problems, and they have with adding something to the du and also just the straightforward ones that we started out with. So I truly want you to pause this video, okay, and try these 4 problems. Okay, did you really pause it? I hope you did, okay? I hope you're not just saying, Mrs. Petrella will go through these for me, okay? So here are the solutions to these 4 problems. So hopefully you can follow my work, and I didn't make any mistakes. But again, you can always check your answers or check my answers by taking the derivative. So hopefully you were able to kind of to arrive at the correct solutions. There are a few more examples in the packet below if you wanted to take a stab at trying those, and we can talk about them on Monday, or you can talk about them with Mr. Fleet or Mrs. Zacchio on Friday, because they are going to come in to help you through the homework problems that you're going to have to do with these. So you will be able to check in with someone to see if you're doing them correctly. Okay? So hopefully you enjoyed this lesson on u substitution, and you have a good sense of what it is. So I thought I'd end this video by saying I hope that you are still on my train, okay, and you're going to do calculus until the end of the year. Okay, so you got to do the locomotion, okay? You can stay on the calc train until the end of the year. I know it. I hope you have a wonderful weekend. You'll get a homework assignment in class tomorrow, and I will see you on Monday.